Hello everyone. Today we are going over the Chapter 8 quiz review, which is over sections 8.1 and 8.2. The first question that you're given says, in a right triangle, theta is an acute angle and cotangent theta equals 6 over 5. Evaluate the other 5 trigonometric functions for theta and show all your work. The answers need to be exact, which basically means no decimals. You're going to have radical answers, not decimals. So take what you're given, the cotangent theta equals 6 over 5, and try to figure out what does that give us. Well, if you know that cotangent is the reciprocal of tangent, and you know that tangent theta equals the opposite over the adjacent, then cotangent theta has to equal the adjacent over the opposite. So if cotangent theta is equal to 6 over 5, then that gives us our adjacent and opposite. So we can use the 6 to represent the adjacent and the 5 to represent the opposite. We still don't know the hypotenuse. So to find the hypotenuse, you're still going to have to use Pythagorean theorem. So if we make ourselves a little right triangle here to see what's going on, if theta is this angle down here, then the opposite, or the adjacent, is the one next to it is going to be 6, and the opposite is going to be 5. So we're trying to find out the hypotenuse. So your Pythagorean theorem says that a squared plus b squared equals the hypotenuse squared. So my hypotenuse is going to equal 5 squared plus, the hypotenuse squared is going to equal 5 squared plus 6 squared. Zoom that in so you can see a little better. So I'll just call it h squared or c squared equals 25 plus 36. So when I add that, I get 61. And then, so if h squared equals 61, the square root of that, h, is going to equal just the square root of 61. The square root of 61 cannot be simplified, so we're just going to say the hypotenuse equals the square root of 61 because we want exact values. And then the 6 is our adjacent and the 5 is our opposite. So now it's just a matter of filling in these blanks with the rest of the picture. So we need to know those pieces of information. So we're going to use 5 for our opposite, 6 for our adjacent, and the square root of 61 for hypotenuse. So going back over here on the left side, sine, you should know that sine theta equals the opposite over the hypotenuse. So my opposite is 5, my hypotenuse is square root of 61. You cannot have a square root in the denominator, so if we rationalize that denominator by multiplying the top and the bottom by the square root of 61, we will get 5 square root of 61 over 61. So that is our ratio for sine. Cosine, the ratio for cosine, theta equals the adjacent over the hypotenuse. Our adjacent is 6, hypotenuse again square root of 61. So when I rationalize the denominator, again I'm going to have to multiply by the square root of 61 over the square root of 61. So the 6 times the square root of 61 will be my numerator, and then 61 will be my denominator. So there's my cosine theta. Tangent is the reciprocal of cotangent, and I already wrote that up here. So your tangent is opposite over adjacent. Your opposite was 5 and the adjacent is 6, or you can just take the reciprocal of the cotangent. So 5 over 6, and we do not have to do any simplifying there or rationalizing the denominator. Cosecant, since it starts with a C, the inverse of it is sine. Make sure you watch your abbreviations closely. So it's the inverse of this one. But instead of rather than using my rationalized answer, I'm going to go back to the original 5 over the square root of 61 and then flip it so that the square root of 61 will be on the top and the 5 will be on the bottom. So that one isn't so bad. And the same with your secant theta. Secant theta is the reciprocal of cosine. So if your cosine originally was 6 over the square root of 61, when we flip it, we'll get the square root of 61 over 6. So there's the first problem for you. The second one is almost the same type of problem, except instead of being given cotangent, you're given sine instead. So let's try that one. So if you're given sine, there should be a theta here. Sine theta equals 18 over 19. Well, sine is, the ratio for sine is opposite over hypotenuse. So if you think about your triangle, let's do that over here to the right. Again, if I just put my, it doesn't really matter which acute angle you put your theta in, I always just go down here in the bottom right. But the opposite is 18, the hypotenuse is 19. So we need to find out what the adjacent is. So we'll call that A. So in order to find A, I'm going to take my hypotenuse squared minus the 18 squared. So 19 squared minus 18 squared will equal A squared. So the 19 squared and the 18 squared, I'm just going to plug that in the calculator. That gives me 37 equals A squared. And then when I take the square root of it, I get A equals the square root of 37. So my adjacent side is square root of 37. The 19 is my hypotenuse and the 18 is my opposite. So again, those are going to be the values that we're going to use in all of our trig functions. Okay, so let's go back over here to cosine. So cosine theta equals the adjacent over the hypotenuse. Your adjacent is the square root of 37. The hypotenuse is 19. There's no simplifying to do there. There's no rationalizing denominator because it's in the numerator. So we can just write down the square root of 37 over 19. Again, we want exact values, no decimals allowed. If we want to, we could do its inverse right now. So the inverse of cosine is secant. So if we were to flip that around, secant, I'm just going to put it up here, secant theta would equal 19 then on the top and your square root of 37 on the bottom. So this one we would have to rationalize the denominator. Again, take your square root of 37, multiply it on the top of the bottom, and that will give us 19 square root of 37 in the numerator over 37 in the denominator. So there's secant. Okay, the next one we're going to do is tangent. So tangent theta equals the opposite over the adjacent. So if you look at your triangle, the opposite is 18. My adjacent is square root of 37. So we will have to rationalize the denominator for this one. So 18 over the square root of 37 is what we're going to start with. Although the inverse, cotangent, when I flip that around, that will be just square root of 37 on the top over 18 on the bottom. So that one won't be that hard. But tangent, we're going to have to rationalize the denominator by multiplying by the square root of 37 over the square root of 37. which gives us 18 square root of 37 over 37. So there's tangent. Now the only one that we have to do is cosecant. Well, cosecant is the inverse or the reciprocal of sine. So if I just take the 18 and the 19 and flip them around, that's going to give me 19 over 18. So there's my last ratio. And there's cotangent again. So square root of 37 over 18. Secant was 19 square root of 37 over 37. Secant 19 over 18, or cosecant, sorry. Tangent 18 square root of 37 over 37, and then cosine is square root of 37 over 19. All right, let's move on to number 3. Now number 3 I'm going to change on your review, so please change this to a 30-degree angle. We're going to apply one of the special triangles, and since the SAT does give you the 30, 60, 90 triangle as a reference, I will do the same. So, and just to make it a little bit harder, we're going to put it backwards. So if my 30-degree angle is here and my 60-degree angle is there, the side that's across from 30 is 1, the hypotenuse is 2, the side across from the 60-degree angle is square root of 3. So those are the values that you use when you set up your ratios. Well, if you look at this triangle, yeah, it's backwards, but we still have the side that is opposite here, and we're trying to find, actually let's go back to what we're doing. We're solving the triangle. So solving the triangle means we have to find the measurements of all the angles and all the sides. So we're given one of the angles and we're given one of the sides. So this is the measurement, so we're changing the 19 degrees, get rid of that, and putting 30 degrees in its place. And we want exact values, no rounded answers. So these are going to be exact, they might be radicals. But angle D is 30 degrees, so we can fill that in here. That's given. The 12 is across from angle E, which means it's side E. So side E is 12. And then F is your 90-degree angle, so we can put 90 degrees here. And then since this is 30, that means angle E has to be 60 degrees. So we can put a 60-degree mark there. So we know our angles, those are pretty easy to figure out, but now the other sides, we're going to use our trigonometric functions. So if we're looking for D, well, D is opposite of the 30-degree angle. So if we're wanting to find the opposite and the 12 is our adjacent, we're going to use sine. So from the 30-degree angle, this is opposite and that is the adjacent leg. So I'm going to use sine of 30 degrees equals my opposite, which is D, I'm trying to find, over 12, which is, or wait, no, I hate making mistakes. Opposite over adjacent is tangent, not sine. Okay, so D over 12 is tangent. Okay, so if I look at my reference triangle here, if I want to figure out what tangent of 30 degrees is, look at your 30-degree angle and then set up a proportion of opposite over adjacent. So tangent 30 degrees is going to equal 1 over the square root of 3. So I can rewrite this tangent 30 degrees as 1 over the square root of 3. Now it's a matter of cross multiplying and solving for D. So if I cross multiply here, 1 times 12 equals 12. D times the square root of 3 is D square root of 3. Now I have to divide by the square root of 3. So D is going to equal, I'll just rewrite that up here. D is going to equal the 12 over the square root of 3, which when we rationalize the denominator, multiply by the square root of 3 over square root of 3, and that will give us 12 square root of 3 over 3, which we can reduce. The 12 divided by square root of, or 12 over 3, since those are both whole numbers, is 4 square root of 3. So side D, we can now write down is 4 square root of 3. And there's your work for it. Now we have to find F. Side F is your hypotenuse. So if we are finding the hypotenuse, and again we want to use the 12 and we want to use the 30-degree angle, adjacent over hypotenuse is cosine. So we're going to use cosine 30 degrees, and that is going to equal my adjacent, which was 12, over the hypotenuse, which is F. Zoom out a little bit so we can see all of that. So adjacent is 12 over the hypotenuse, which is F. If we look at our little reference angle here, if our 30-degree angle is here, so we're trying to find cosine of 30 degrees. So 30 degree cosine of 30 degrees is the adjacent, which is square root of 3, over the hypotenuse, which is 2. So I'm going to rewrite the cosine 30 degrees as square root of 3 over 2 equals 12 over F. And then again, we're going to cross multiply and solve. So when I cross multiply, the square root of 3 times F is just square root of 3 times F equals 2 times 12, which is 24. I'm going to have to divide by the square root again, which means I'm going to have to rationalize the denominator. So multiply by my square root of 3 over square root of 3. So I'll get 24 square root of 3 on the top over 3 on the bottom. And then you can divide 24 by 3, which gives us 8 square root of 3. Okay, so one of the things that you might notice is that the smallest side and the largest side, the hypotenuse is always 2 times the size of the smallest. So that's something that you can use to check your answers or to even find your answers. So once you know what the smallest side is, you could just double it to get your hypotenuse. So I could have just taken 4 square root of 3, doubled it, gotten 8 square root of 3. But again, that takes knowing your ratios. So knowing that this is 1 and that's 2, so the smallest side, the side across from the 30-degree angle, if you double it, will give you the hypotenuse. Or if you take half of your hypotenuse, that's going to give you the smallest side. So those two sides are nice in that way. All right, moving on to number 4. Now number 4, we are going to use a calculator, and you're going to round to the hundredths. So you will have a problem like number 3, where you're going to have a 30, 60, 90 triangle, or maybe a 45, 45, 90 triangle. And then you'll also have, ignore that interruption. All right, you're also going to have one that is not a special triangle, which you'll have to use the calculator, but you're going to round to the hundredths, so that's 2 decimal places. Okay, so again, let's look at the given information. Your given angle D is 39 degrees, so we could fill that in. We know that angle F is the 90 degree angle, so we could plug that in. And then if this is 90, then these two here should add up to 90. So I could just take 90 minus 39. If I take my 90 minus 39 and borrow, could use my calculator, but I'm not going to get it out. So that's going to be 551 degrees. No. Yes, that's going to be 51 degrees. Sorry. For a second there, I was thinking they had to add up to 80, but they have to add up to 90. So if you check, they do add up to 90. So we're good to go there. Now we have to find the angle measurements. So if you look at the one that's given, you're given the hypotenuse. Since that's across from angle F, then little f is our hypotenuse, 22. So we need to find the adjacent and the opposite. So it doesn't matter which one you want to start with. So if I'm using this angle, the side D is opposite, and the 22 is my hypotenuse. So I can use sine. Sine is opposite over hypotenuse. So sine of 39 degrees is going to equal D over 22. So we don't know what sine 39 degrees is without a calculator, so we'll plug that in the calculator, but let's solve for D first by multiplying both sides by 22. So that's going to cancel out, so then D is going to equal 22 times sine 39 degrees. Okay, so in my calculator, I want to first of all make sure that I'm in the right mode, make sure that you're in degrees because we're working with degrees. And I would just type in 22 times sine 39, hit my equals, and then round to 2 decimal places, so it's going to be 13.85. And it's not a degree measurement, it's a side length, so 13.85. All right, so we're not going to use that value, or we're not going to use the Pythagorean theorem to get the other side because this is a rounded value. We want to be as accurate as possible. So to find E, which is our adjacent, we're going to use cosine because cosine is the adjacent over the hypotenuse. So let me write that over here. There's more space. Cosine of 39 degrees is going to equal the adjacent side, which is the letter E, over hypotenuse, which is 22. Again, you would just have to multiply by 22 on both sides to get the E by itself. So E is going to equal 22 times cosine 39 degrees. So if I look at my calculator, I've already got the 22 up there, but I could, well, I'll just rewrite it. 22 times cosine 39 degrees equals 17.09. Now that 9 needs to round up. So if that 9 needs to round up, then this is going to become a 10. So 17.10. You have to have that 0 so that it's rounded to 2 decimal places and has 2 significant figures. So 17.10. All right, so those are the answers for number 4. Okay, moving to the back side. Number 5. Again, we're evaluating the 6 trigonometric functions, but we're not given one of the functions. Instead, we're given the triangle. And we're going to, answers should be exact. And I also want to put and simplified. So definitely needs to be fractions, but you want to simplify your fractions. It's okay to leave them improper, but they should not have any common factors in the numerator or denominator. All right, so again, knowing your SOHCAHTOA kind of helps. So if you want to write it down, sine theta equals the opposite over the hypotenuse. Cosine theta equals the adjacent over the hypotenuse. So we'll just start with those. So if I look at where theta is, so here's my theta. So the side that's across from it is my opposite. So 9 is my opposite leg, and the 40 is my adjacent leg, and we're missing the hypotenuse. So we'll call that h. But Pythagorean theorem says that a squared, so the 2 legs squared equals the hypotenuse squared. So I can figure out h squared equals 40 squared plus 9 squared. I'm going to use my calculator to plug that in, and okay, I don't have the 40 squared plus 9 squared, I just have that h equals 41. So in my calculator, what I probably did is I took the square root of both sides and put that in parentheses. So h would equal the square root of 40 squared plus 9 squared, and then close my parentheses. And then that gave me the 41. And it was an exact value, which was nice, so we don't have any radicals. How convenient. All right, so now we've got our hypotenuse, which is 41. So now it's just a matter of writing them down. So your tangent or sine is opposite over hypotenuse. So the opposite is 9, hypotenuse is 41. And that cannot be reduced, so you're done with that one. Your cosine is the adjacent over the hypotenuse. Adjacent is 40, hypotenuse is 41. So 40 over 41. Your tangent is the opposite over the adjacent. So if I take my opposite, that's 9 over my adjacent, which is 40. Again, that cannot be reduced. But if you do have a fraction that can be reduced, you do need to reduce it. Your cosecant, since it starts with a C, the inverse or the reciprocal of it is the one that starts with an S. So 9 over 41, if we flip it, will become 41 over 9. So make sure you look at these abbreviations. So the secant now is in reciprocal of cosine. So if I flip that one, I get 41, or no, 40. Yeah, no, 41 over 40. And then your cotangent is the inverse or the reciprocal of tangent. So when we flip that, we get 40 over 9. So that one isn't too bad. Let's try the next one. Again, your answers need to be exact. You're not going to put any decimals, and you're going to reduce the fractions if you need to. And I can tell already we're going to have some reducing going on because 10 and 8 can both be divided by 2. But we still need to find this third side. However, this time you're given the hypotenuse. So to find the third side, I would say my hypotenuse squared minus the 8 squared is going to equal my opposite. So I'll call that x squared. Doesn't really matter what variable you use. So if I take 100 minus 64, I get x squared. 100 minus 64 is 36, which is a nice perfect square. Taking the square root of it would give me opposite that was 6. So that's my opposite. This is my adjacent, and the 10 is the hypotenuse. So now it's a matter of plugging them in and simplifying. So sine is opposite over hypotenuse, so 6 over 10. But I'm going to write it up here because I know it can be reduced. I can reduce that by 2, which will give me 3 over 5. And then if I want to look for the reciprocal, since that starts with an S, its reciprocal starts with a C. So if I flip that 3/5, it's going to be 5/3. So that one's done. Cosine, if I look at cosine, cosine is the adjacent over the hypotenuse, so 8 over 10. And 8 over 10, we can divide both of them by 2, which will give us 4 over 5. And then its reciprocal is secant. If we flip it, we get 5 over 4. And then last but not least, we're going to use a new color here. Tangent is the opposite over the adjacent, or 6 over 8. But 6 over 8 we can reduce to 3 over 4. And then the reciprocal of that, when we flip it, will become 4 over 3 for my cotangent theta. Okay, so those hopefully weren't too bad. The next part, we are moving on now to section 2. And in section 2, we learned how to draw angles in standard position. So you're asked to draw a 260-degree angle. Since it's positive, I'm going to mark my degrees, the 0 degrees here, when I go counterclockwise, so up and around, this would be the 90-degree mark. If I keep going around, this is the 180-degree mark, and then this one here is 270 degrees, and then all the way back to the beginning would be a full 360 degrees. So if I'm going 260, if I'm looking at these numbers, well, 260 is just a little bit shy of the 270. So I want to end up about here. Your initial side is always starting from the center and pointing towards 0. So you have to have both sides of your angle, the initial side and the terminal side, but you also need to show what direction this is rotating with the arrow. So I'm going to just start here and go around and put my arrow there. So that's showing that it's a positive 260 degree angle. Okay, that's all you need to do for 7. Number 8 is similar, but it's a negative angle. So if you're asked to draw a negative angle, rather than marking the 0, 90, 180, and 270, I'm going to mark the negative angles, measurements, because if you're going negative, you're going to go down and around. So this is going to be a negative 90 degrees down here. If I go this way, it's going to be a negative 180 degrees. Keep going around, that's going to be a negative 270 degrees, and then back to the beginning would be a negative 360 degrees. So we are drawing a negative 115 degree angle. So 115 is what, 25 degrees more than 90. So it's going to be not halfway, because halfway would be 45. So about a third of the way is where we want this to end up. And again, your initial angle is here. So it actually ends up looking very much like the last one. But instead of going in the positive direction now, we are going in the negative direction. So you have to have both sides to the angle, your initial side and the terminal side, and then you have to show that this arrow has to be on your drawing, showing that it's going in the negative direction and that it's a negative 115 degrees. Good. All right, so the next problem, number 9 and 10, well, 9, 10, 11, and 12, we're converting, we're just changing units of measures from degrees to radians or from radians to degrees. And to show all your work, you have to show the conversion rate. So the 245 degrees, I'm going to put it over 1. And since I want to get rid of degrees, the 180 degrees is what I'm going to put in the denominator, and then at the top, since I want to convert to radians, pi goes in the numerator. So I could just multiply across 245 pi over 180, but you do need to simplify. Now the degrees do go away, so it's just 245 pi over 180. Now if you don't know, you could use your calculator to reduce this, or we can divide by 5 and just keep reducing the fraction. But on my calculator, if I just hit 245 ABC, so I do my fraction button, 180, and hit equals, it will reduce it for me, but it puts it in a mixed number. I don't want a mixed number, so it has to be improper. So I'm going to hit second ABC, which says mixed number to improper, so that's what those symbols mean. And hit equals, I'll get 49 over 36, which is what I would have gotten had I divided both of those numbers by 5. So 49 pi over 36 radians is what we're going to get when we convert 245 degrees. So 245 degrees is equal to 49 pi over 36 radians. Okay, we have one more of those. This time we have 95 degrees, a little bit smaller number. 95 over 1 times, so the degrees, again, we're trying to get rid of degrees. So put the 180 degrees at the bottom and pi at the top. Multiply across, I get 95 pi over 180. I can then reduce it by 5. So 95 divided by 5 would be 19. Still have a pi there. And then 180 divided by 5 would be 36. And then 19 and 36 do not reduce. So that is your simplified answer. We should put radians because it is a unit of measure. Just like inches or feet, we want to say what the unit of measure is. So 19 pi over 36. Almost done. 3 more to go. All right, number 11, we are converting now our radians, which has pi in it, to degrees. Again, we're going to start by writing our fraction, and we're going to multiply it by our conversion factor, but instead of pi over 180, we're going to flip it and put the 180 at the top and the pi at the bottom, so that then we can reduce the pi that's on the top and the bottom. You could also reduce the 180 with 10, or you could wait. So 9 times 180 over 10, so I would reduce the 10 and the 180, giving me 18, and then 9 times 18 would equal 162 degrees. So we do want to put the degree mark because that's your unit of measure. And then number 12, we have a negative angle, which just means our answer is going to be negative. So a negative 68 pi over 45, multiply by, put the pi on the bottom so that it reduces with the pi on the top, and then the 180 goes at the top, and it's going to be degrees that we're going to end up with. So again, the pi reduces, and rather than multiplying the 68 times the 180, I'm going to probably try to reduce what I can. So the negative 68, I'll probably leave that alone, but I know that my 180 has a factor of 9 in it. So 9 times 20, and then 45 is 9 times 5, so then I can reduce the 9s. And then I can reduce the 5 with the 20, and that will give me 4. So now my denominator's gone, and then just multiply your negative 68 times 4, and we're going to get a negative 272 degrees. All right, and then the last one here, you have to find 2 positive and 2 negative coterminal angles with 216 degrees. On the quiz, you'll only have to find 1 or something that's similar to this, but I wanted you to find 2 on the review just so that you can see that how to find more than 1, I guess. So to find so we cannot have 216 cannot be one of our answers. You're going to take your 216, and a coterminal angle just means it's going to go around the circle another 360 degrees. So if I add 360 to the 216, we're going to get 576. Separate those 2 columns there. So 576 is degrees, and that is 1 positive coterminal angle. Well, if I would like to find another one, if I subtract 216, that's going to give me a negative, or if I subtract 360 from 216, that's going to give me a negative coterminal angle. So rather than doing that, I'm just going to add 360 again to the 516. That just means I'm going around the circle again. So that gives me 6, 13, carry the 1, 936 degrees. So now I have 2 coterminal angles that are positive. And to find 2 negative coterminal angles, we're just going to subtract rather than adding to the 216 minus 360. So I'm going to do that over here. If I take 216 minus 360, and I'll let my calculator work this one out, I get a negative 144 degrees. So that is a negative angle. That is one negative coterminal angle. And then to find another one, I would just subtract 360 degrees again. So again, if I plug that in my calculator, well, now since they're both negative, I can add. That makes it easier. So that will be a negative 504 degrees. So we just found two positive and two negative coterminal angles with the 216. Notice that 216 is not one of our answers. And that's the end of our review. Good luck on your quiz.